Welcome to your second video class on your review for exam 3 for your Math 152 College Algebra course. We will continue where we left off on the first video. We're on question 10. This one only has one step and it's worth 8 points. We have a function here, and it asks us to find g of x and h of x such that the given function f of x is g of h of x. So basically, we need to rewrite this as the decomposed functions. This is the decomposition of two functions. So we're going to try to identify an inside function and an outside function. The inside function is going to be our h of x. So if I'm looking at the given f of x, I can see that negative 3x cubed plus 1 is clearly inside of something. So I'm going to call my inside function h of x negative 3x cubed plus 1. G of x is my outer function. So what can I say would be the outer function if the part that's in purple is the inner function? Well, the outer function would be the square root of that plus this 5. So I could say that my g of x function is the square root of x plus 5. Other questions on the decomposition of functions? Okay, let's move on. Question 11. Find a formula for the inverse of the given function if possible. To find the inverse of a function, first of all, we are going to replace p of x with y. Replace the function notation with y. So we write this as y equals the fifth root of x cubed plus 2 minus 3. Does anybody remember the second step when we're finding an inverse? What do we do algebraically? Yes, we switch x and y. So I'm going to switch the x's and y's. This becomes y cubed plus 2 minus 3. And then what algebra has to happen? After we switch x and y, we solve for y. We solve for y. So here, if I want to get the y alone, I'm going to begin by adding a 3 on both sides. So that will give me the quantity x plus 3 equals the fifth root of y cubed plus 2. Okay, now if I'm trying to get the y alone, I need to undo the fifth root. So to undo fifth root, I'm going to raise to the fifth power on both sides. Thankfully, they are not going to expect me to multiply this binomial by itself 5 times. I can just write quantity x plus 3 to the fifth is equal to, fifth root cancels with the fifth power, y cubed plus 2. Next, trying to get the y alone, our next step is going to be to subtract 2 on both sides. So I've got y cubed on the right, and on the left, the quantity x plus 3 to the fifth power minus 2. Last, take the cube root to undo y to the third, cube root of both sides. So that gives me y is equal to the cube root of quantity x plus 3 to the fifth minus 2. And then you're going to replace y with the inverse notation. So the inverse notation is already here on the screen for you. All we have to type in is the cube root of the whole quantity quantity x plus 3 to the 5th minus 2. The tricky part here is making sure that your parentheses are in the right place, that your square root goes over the right portion. All right, moving right along. Question 12. Find the formula for the inverse. We're going to do the same thing. We're finding an inverse. So again, step 1, we're going to replace the k of x with y. Step 2, we're going to switch x's and y's. So this would be rewritten as x equals y plus 2 over 2y plus 3. Step 3, we're solving for y. Well, the fact that I have a y in a denominator is inconvenient, and I need to get it out of the denominator. We can think of this as fraction equals fraction and think of cross product here. So if I cross multiply, that would give me 2xy plus 3x equals 1 times y is y and 1 times 2 is 2. Y plus 2. Okay, my goal here is solve for y. So what I would like to do here is get all y's on the same side of the equal sign and all non-y's on the other side of the equal sign. So just by doing a little rearranging here, I'm going to subtract 3x from both sides, and I'm going to subtract y from both sides. And that is just to get all the y's on the left and all non-y's on the right. So on the left side, I'll end up with 2xy minus y. On the right side, I end up with 2 minus 3x. Okay, on the left side, again, the goal is to get the y alone. So what I will do is factor y as a GCF on the left side. So that both terms contain y. Factoring it out, I'm left with quantity 2x minus 1. And last, to get the y isolated, I undo multiplication with division. So divide by quantity 2x minus 1, divide by quantity 2x minus 1. That gets the y alone. I think I'm going to turn that numerator around and write that as negative 3x plus 2 over 2x minus 1. It's not wrong the other way. I just like the way that looks better. And then, of course, y gets changed to this inverse notation. So k negative 1 of x would equal fraction negative 3x plus 2 over 2x minus 1. Questions? All right, moving on. Number 13. Determine the x-intercepts, the y-intercept, and the correct graph of the polynomial function. Enter all points as ordered pairs, separate multiple answers with a comma, and select the graph from the options labeled A to D below. All right, so we've got a quadratic function. First of all, let's talk the easy one. This is given to us in what we call standard form. Ax squared plus bx plus c. It's in standard form, and I need you to know that c, the constant term, is always the y-intercept. So what is the y-intercept of this graph? 0, negative 3. Thank you for giving me that as an ordered pair, because you do have to enter it as an ordered pair. Okay, so just taking a look at graphs A, B, C, and D, do you see any graphs we're going to eliminate from answer choices right now? I think graph D does not pass through negative 3 on the y-axis, going through a positive, so we can eliminate that as a choice. Also, graph B, if you look at the degree here, it's a second degree. It's a quadratic function. This one's cubic. So we got it down to A or C just by taking a look at the y-intercept. Okay. Now, let's talk about the solutions. I'm going to specifically look at this and see if it will factor. X squared minus 2x minus 3. if you set this equal to 0, you can factor it by listing the factors of -3 that will give us a sum of the middle coefficient, -2. So what can I multiply that gives -3 that adds to be -2? 1 and -3. Okay, so if I multiply those, I get -3, but if I add those, that adds to be -2. So 1 and -3 are the winning factors. So this factors into two binomials. The first binomial is going to get a +1. The second binomial will get a -3. Then according to the zero product property, if I multiply this factor times this factor and I get 0 for a product, then either of those factors could equal 0. So x plus 1 could equal 0, x minus 3 could equal 0. My two solutions, or x-intercepts, are -1 and +3. So -1 and +3 are the x-intercepts. -1, 0, and +3, 0. Separate multiple answers with a comma. And then take a look at those two graphs. A or C? C. C is crossing at -1. You see this scale here, this would be -2. So -1's here in the middle, and crossing at 3 between 2 and 4 would be a 3 right there. So -1 and 3 are the x-intercepts. All right, questions? Moving along. Question 14. Solve the polynomial inequality. We did these, and we did these by examining the graph. Can you tell me the degree of this polynomial function? If I multiply all of this out, what's the degree? X to the third, because it'll be x times x times x. So it's going to be a degree of 3. That tells me it's a cubic. So it looks like this if the leading coefficient is positive, and it looks like this if the leading coefficient is negative. Is the leading coefficient going to be positive or negative? Negative. How do we know that?
Because the last x there is negative.
Yes, if we take positive x times negative x, I will get negative x to the third. So the leading coefficient is negative, so here's my general shape. Okay? Now, next, let's consider what the zeros are for the x-intercept. So if I were to sketch an x and y axis and plot points where the zeros of this function would be, what 0 does that factor correspond to? 5. So let's say there's going to be a 0 at 5. Okay? What 0 does that factor correspond to? -2. So at -2, there's going to be another 0. And what 0 does that factor correspond to? 3. +3. So at 3, we'll have another 0. Okay, and we already said that the general shape is going to be going up on the left and down on the right. So we're going to sketch this in. There's the general shape of our graph. Now the question is asking where this function or where the graph is less than 0. Less than 0 is going to be under the x-axis. If it is a greater than 0, we would have been talking about above the x-axis. So where is it less than 0? It's less than 0. Sorry, that should have been an open point. Less than 0 on this interval, and it's less than 0 on this interval. Okay, so where I have traced in purple is where the function is less than 0. So, because it said less than, I use those open points, which also is going to correspond in interval notation to curvy brackets instead of square brackets. So, the first interval that's less than 0 is the interval from -2 to 3. Union with, the second interval would be from 5 to positive infinity. If there had been a less than or equal to, then I would have included this point, and this point, which would have given me square bracket, square bracket, square bracket. Of course, it wasn't that, but I just want you to know if that were the case. Any questions? Let's move on. Question 15. This one's 2 steps. Step 1, graph the polynomial function. Plot the x-intercepts, if any, of this function on the graph. Click on the graph to plot a point. You may move the point around by clicking and dragging. Well, first of all, you've got to tell the computer how many x-intercepts this particular function has. So we have 4 linear factors, and that's going to give me an x-intercept of -1, -2, +2, and +1. So there are going to be 4. So you're going to click that, and it's going to enable you to plot 4 points on the screen. So I'm going to plot a point where those would be at -1, at -2, at +2, and at +1. Okay, so there is the first step in this problem. In the second step, it's got those 4 zeros there for you. You should have plotted. And it starts shading regions of the graph, and it asks you in the highlighted region, determine whether the function is positive or negative. If the function is positive, click above the axis. If the function is negative, click below the axis. You can determine that by substituting any number in. So I could choose to substitute in -5 if I want to, in here, 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 and here for x, and determine is it above or below. But we should know our functions a little better than that at this point. This one is a quartic. It looks like a W, okay, because it's 4th degree. Is the leading coefficient positive or negative? Well, x times x times x times -x is going to be -x to the 4th. So it is a upside down W with the M. So it's going to have this general shape. Sorry. So we know the general shape has to be like that because the leading coefficient is negative. So what I'll do is I would click anywhere down here, and it'll plot that part. Then I would click anywhere up here. Then I'll click anywhere down here, click anywhere up here, and then anywhere down here. So you click above the x-axis, or below the x-axis, above the x-axis, below, above, below, above. Does that make sense? You guys remember how that works? Okay. Moving right along. Question 16. Use polynomial long division to rewrite the following fraction in the form quotient plus the remainder over divisor, where d of x is the denominator of the original fraction, or the divisor here. That's the divisor. Q of x is the quotient. R of x is the remainder. This is division by a divisor that has a degree greater than 1. When that degree is greater than 1, you're not going to be able to sneak in and do synthetic division. You're going to have to use polynomial long division because we're dividing by something of a degree greater than 1. So here we go. I'm going to give myself some space. When I do polynomial long division, I'm going to say x squared plus 0x plus 1. I'm not going to skip any powers. I'm going to use 0 coefficients and write all terms in descending order. I'm dividing this into the divisor 2x to the 4th minus 4x to the 3rd plus 3x to the 2nd plus 4x to the 1st plus 3, and that was in descending order and no powers were skipped. So, long division, I will remind you, the algorithm is daddy, mommy, sister, brother. Daddy, mommy, sister, brother. Daddy, mommy, sister, brother. D, daddy, stands for divide. So you're going to say, what is 2x to the 4th divided by x squared? Or what could you multiply by x squared to get 2x to the 4th? 2x squared. Okay, then m, mommy, that means multiply. So multiply through 2x squared by all terms of the divisor. 2x squared times x squared is 2x to the fourth. 2x squared times 0x is 0x to the third. 2x squared times 1 is 2x squared. That's mommy. S, sister, stands for subtraction. So we will subtract. When we subtract, we're subtracting a quantity, which means distribute the negative in. So distributing in the negative, then combining straight down. So 2x to the fourth plus negative 2x to the fourth cancels. Sorry about that. Negative 4x cubed minus 0x cubed is negative 4x cubed. 3x squared minus 2x squared is 1x squared. And brother, daddy, mommy, sister, brother, means to bring down the next term. Okay, back to daddy. For daddy, we will say, what can I multiply by x squared to give me negative 4x cubed? And that would be negative 4x. Mommy, I'm going to multiply negative 4x by all terms of the divisor. So negative 4x times x squared is negative 4x cubed. Negative 4x times 0x is 0x squared. Negative 4x times 1 is negative 4x. Okay. There's mommy. Sister means subtract, so I'm going to wrap it up in parentheses, subtract the quantity, distribute the negative. It becomes plus, positive, negative, positive. Adding down, 4x cubes cancel. 1x squared minus 0x squared is 1x squared. 4x plus 4x is 8x. And brother means bring down. So I'm bringing down a plus 3. Back to the same algorithm. Daddy, mommy, sister, brother. What can I multiply by x squared to get x squared? X squared times 1. So then we multiply by 1. So 1 times all of this is just going to be x squared plus 0x plus 1. There's my multiplication by 1. Sister is subtract. Distribute in the negative. So plus a negative minus minus. X squared minus x squared. We're combining. I cancel. 8x minus 0x is 8x. 3 plus negative 1 is plus 2. 8x plus 2 will be my remainder. So the way that I'm going to write my final answer is, this is my quotient in purple. Here's my quotient. And then I'm going to write plus my remainder, 8x plus 2, over the original divisor, x squared plus 1. This is what we input into the box and hit enter. Breathe. We're 24 minutes in. Number 17. Synthetic division. To determine if the given value for k is a 0 of the polynomial. If not, determine p of k. I'm going to tell you, you don't have to use synthetic division. You can, but you can use the remainder theorem here. I love the remainder theorem because if you've got this as a potential 0, you can say, if this is a 0, I'm going to substitute k in and it'll give me 0. If it's not a 0, then it's going to tell me what the remainder would be if I divide by it. So is k a 0? Here's how I'm going to do this. I'm going to find p of 3. So it'd be 2 times 3 cubed minus 2 times 3 squared minus 9 times 3 minus 23. And then I can input that line into a calculator and find out what that equals. Has anybody done it yet? What is it? Negative 14. Did anybody else get negative 14? Anybody? Yep, I got negative 14. Okay, so P of 3 is equal to negative 14. So the question says, is K a 0 of a polynomial? Yes or no? No. No, it's not. Okay, if you say no, then it's going to ask you, what is P of K? And it'll give you a box to put it in. Well, you've already found it here. If you've used the remainder theorem, you've already found it, and it is negative 14. The other way would be to perform synthetic division. Use 3 as the multiplier and write the factors, or the coefficients, sorry, 2, negative 2, negative 9, and negative 23. Go all the way through synthetic division, which isn't bad. 3 times 2 is 6, add down, get 4. 4 times 3 is 12, add down, get 3. 3 times 3 is 9, add down, get negative 14. Here's your remainder. Okay, so this would be your value for P of K. So there's 2 ways to do it. Actually, that might have been faster. Okay. All right, moving right along. Use synthetic division to rewrite the following fraction in the form we're just dividing, where D is the denominator of the original function, Q is the quotient, R is the remainder. So we can use synthetic division here because our degree is first degree. And there's no leading coefficient in front of x. So what we say is this plus 3 gets a sign change, and minus 3 is what's being tested as a 0. Okay? So negative 3 is your multiplier. And then we're going to write all the coefficients, but we don't want to skip any powers of x. So if you look at the original dividend, that numerator, are there any powers skipped? 6, 5, we're missing x to the 4th. So I'm going to use 0x to the 4th, 3, 2, 1 constant. So I will have a 0 coefficient in my work, okay? So I'm going to say 2x to the 6th plus 6x to the 5th plus 0x to the 4th minus 4x to the 3rd minus 12x to the 2nd plus 5x plus 15. So again, right there, if you leave that out, it's going to throw your answer off. Okay? So now, completing synthetic division, begin by bringing down the 2. Multiply. Any number that comes under the line gets multiplied by our multiplier. So negative 3 times 2 is 6. Sorry. Negative 6. And then we add down. 6 minus 6 is 0. And I'm going to multiply. Negative 3 times 0 is 0. Then I add down. I get 0. Then I multiply. Negative 3 times 0 is 0. Then I add down. I get negative 4. Multiply. Negative 3 times negative 4 is positive 12. Then I add down. I get 0. Then multiply. Negative 3 times 0 is 0. Then I add down. I get 5. Multiply. Negative 3 times 5 is negative 15. And I add down. I get 0 for my remainder. Okay. So to write the answer, I know my remainder is 0. I'm going to start my quotient with 1 degree lower than the original problem. So the original problem started with 6 degrees. You're dividing by x to the first power. So if I subtract powers in division, 6 minus 1 would be 5. So my quotient begins with the 5th power. So my answer will be 2x to the 5th. This would correspond to x to the 4th. Might want to label them x to the 3rd, x to the 2nd, x constant remainder. Okay, so my quotient will be 2x to the 5th. There's no x to the 4th. There's no x to the 3rd. Minus 4x squared. There's no x. Plus 5 for a constant. And there's no remainder. So this is the final answer that goes in the answer box. 31 minutes and counting. Okay. 19. Given the following rational function, find the equations for the vertical asymptotes, if any, for the rational function. Set the denominator equal to 0. There's your vertical asymptote. The only reason there wouldn't be one is if there's no x in the denominator, or if the numerator factored and canceled with the denominator. In that case, you would have a whole instead of a vertical asymptote. Next part. Find the equations for the horizontal or oblique asymptotes. This is where we got to consider the degree of the degree of the numerator and the degree of the denominator. So it's a case 1, case 2, or case 3. Here, the degree of the numerator is 1. The degree of the denominator is 1. So the degree of the numerator and denominator is the same. In that case, I believe it was a case 2 when we took notes on this. We would say y equals the leading coefficient of the numerator is going to be the number in front of x, divided by the leading coefficient of the denominator, the number in front of x. So I have a horizontal asymptote at y equals 2. When the degree of the denominator is greater, if I had 2x minus 2 over x squared plus 6, it's supposed to be 6, plus 6. If I have the degree in the denominator being greater, then I have an automatic horizontal asymptote at y equals 0, which is right on the x-axis. If the degree of the numerator is greater, you don't have a horizontal asymptote. That's when you have maybe oblique, and you have to do division. Okay. Next, given this rational function, enter 4 ordered pairs on the graph. So this is where we pick a number, any number. I like 0. So if I substitute in a 0 for x, and maybe if I substitute in a 1 for x, and maybe if I substitute in a 2 for x, and 3 for x, that's going to be the start of my 4 ordered pairs. So if I substitute in a 0, 2 times 0 minus 2 is negative 2. 0 plus 6 is 6. I would get negative 1/3. Better reduce. Okay? If I were to substitute in a 1, substitute in 1, 2 times 1 minus 2 will be 0. And 1 plus 6 is 7. 0 divided by 7, I get 0. If I substitute in a 2, if I substitute in a 2, 2 times 2 is 4, minus 2 gives me 2, and 2 plus 6 is 8, and 2/8 is 1/4. Be sure you reduce. And if I substitute in a 3, 2 times 3 would be 6, minus 2 would be 4, and 3 plus 6 is 9. I would get 4/9. It's fairly easy to come up with 4 ordered pairs. Just be sure if you have a reducible fraction, you reduce it. Unless you like the idea of partial credit. Alright, given this rational function, find vertical asymptotes, if any. Here I am going to consider if that numerator would factor. and I'm going to guess. I'm going to guess that one of the factors is negative 9x minus 2. If one factor of the numerator is negative 9x minus 2, what would I multiply by negative 9x to get 45x squared? Negative 5x, right? And if negative 9x minus 2 is a factor, what would I multiply by negative 2 to get 4? This is my guess. Now I'm going to check to see if those really are factors. Negative 9x times 5x will be 45x squared. Negative 9x times negative 2 will be positive 18x. Negative 2 times negative 5 will be positive 10x. And look at this. 18x plus 10x is 28x. Yeah, that's it. Negative 2 times negative 2 is 4. So these are the factors. So what happens here is negative 9x minus 2 cancels with negative 9x minus 2. Telling me here there are no vertical asymptotes because it canceled. Now what about horizontal and oblique? Look at the degrees. Can't see it. Look at the degrees. The numerator is exactly 1 degree greater than the denominator. It's going to have oblique. And guess what your oblique asymptote is going to be? Every time you have to divide to get it. But if you've done this canceling, you've already divided. Right here it is. Your oblique asymptote is y equals negative 5x minus 2. If you've done the factoring and canceling is just like dividing. You have divided. Then it's asking me for 4 points, and I'm going to skip that. It's going to take some time, and I think we would rather... Oh, that's the last one. I'm still going to skip it because we have 3 minutes to end the class. I'm going to end the video here. Okay? So best of luck studying for your test. You can watch this video as many times as you please. I'm sure this will fill your day with brightness and sunshine. So, good luck making A.